Okay, binomial theorem, 8.5. Here we go. So if I'm going to take a binomial, which would be x plus y here, this is a binomial, has two terms in it, raise it to the 0 power, notice that I would get a 1 out of this because anything raised to the 0 power would be 1. If we take x plus y and raise it to the first power, we would just get back x plus y. If we take x plus y and raise it to the second power, we would get an x squared plus a 2xy plus a y squared. Don't forget that 2xy in there. So the thing that I want you to notice here is that if I have a 0 exponent, I have exactly one term. If I have a 1 exponent, I have exactly 2 terms. If I have a 2 exponent, I have exactly 1, 2, 3 terms. So the question is, if I have n exponents, I would have n plus 1 total terms, right? That's what I would have for that one. So the first thing you want to notice that is when we're taking a binomial and we are raising it to the power of n, we will have a grand total of n plus 1 terms. So if I had x plus y to the 7th, how many terms would I have? I would have 8 terms total. All right, the next part of the binomial theorem has to deal with this thing called n choose j, or n over j. So you'll see two forms. It'll either be in this form, parentheses n and j, or it'll be in n cj. I will use this form more often in class when we're talking about probability. I'll use this form when we're talking about the binomial theorem. All right? So what this means is this means n objects chosen j at a time. And it's not so important that we understand what that means exactly for right now. What's important, though, to understand is to use the binomial theorem, we actually have to understand what the formula is to compute n choose j. So the formula for us is going to be n factorial all divided by j factorial times n minus j factorial. So this part right here, this is the piece that we need to understand. So this is called n choose j. And let me give you some examples for that. All right, so two examples for this. 10 choose 3 and 23 choose 17. So 10 choose 3 literally means 10 factorial all over 3 factorial times 10 minus 7 factorial. Well, that's just equal to 10 times 9 times 8 factorial, all divided by 3 factorial. 10 minus 7 is a 3 factorial. Oh, shoot, sorry, this is backwards. It should be 10 minus 3. There we go, factorial. So then this will give me a 7 factorial. So notice then if I just took this out to 10 times 9 times 8 times 7 factorial, all divided by 7 factorial, those would cancel out. And I'm left with a 2, a 3 times 2 times 1. So when this is all said and done, you end up with 120. So let me show you where this is on the calculator as well. So take your calculators out, if you haven't already done so. And let me show you where this button is for you guys to work on this. So hit play, and then move this down here. Sorry. Okay, so 10 choose 3. Here we go. Turn your calculator on, hit 10. Then go to the math button. And then over here on PRB, notice that your third option is an NCR. So the same spot where the factorial is, go to the third. So I have 10 NCR, means N choose R, and I want to do 3. And notice we get 120, which is what we got down here. So for part B, let's do 23 math choose 17. And notice we're getting 100,947. So this is going to be 100,947. You need to know both the formula and how to do it on the calculator as well. All right? We do have two special cases to talk about. This is box number 4. And those cases are this. 1, what do you think n choose 0 is? So if I have n objects and I want to choose none of them, well, there's only one way I can do that. The answer would be 1. N choose 1. So for example, or n choose 0. Let's say I have 6 choose 0. There is only one way to choose nothing from 6 objects. That's it, okay? So what do you think this one then would be? Case number 2. If I want to choose n, choose n. this is also the number 1 because there's only one way to choose every object from a collection of objects, right? So if you have 5 math, choose 5, there's only one way that can happen. So there's only one way to choose nothing from objects, and there's one way to choose everything from objects. That's what this is saying. We'll talk more about that when we get to probability. All right, the next little bit of information that we're going to talk about when talking about the binomial theorem is Pascal's triangle. And I think many of you have seen this before. Pascal's triangle looks like this. It is 1, and then 1, 1, and then 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and so on and so forth. So hopefully you are seeing the structure in the pattern. I'll point it out to you. In order to get this 3 here, we had to add these two together. 2 and 1 gave me the 3. In order to get the 6 here, I had to add these two together. 3 and 3 gave me 6. In order to get this 4 here, I had to add that and that together. 1 and 3 gave me the 4. So there is definitely a lot of structure going on in Pascal's triangle. That means the next line would be 1, 4 and 1 together would be 5, 6 and 4 together would be 10, 10 and, or 6 and 4 again would be 10, 4 and 1 would give me 5, and then the outside is 1s. So we definitely have these outside 1s going on, but then there's also this structure that's sort of built into it. And what this does is this tells us a lot of information about binomials. Let's call this the 0 row. Let's call this the first row. Let's call this the second row. Let's call this the third row, and so on down the line. Okay, you should notice that this should ring a bell because in the very first box I asked you what was x plus y raised to the 0, and the answer was a 1. Well, there's a 1 right there. Then I asked you what x plus y to the first was, and it was x plus y. Notice there's a 1 in front of the x and there's a 1 in front of the y. Well, there's a 1 there and there's a 1 there. Now check this out. What about x plus y quantity squared? The answer was x squared plus 2xy plus y squared. If I look at the coefficients, I'd get a 1, a 2, and a 1. Oh my gosh, there it is, a 1, a 2, and a 1, right? So therefore, if I wanted an x plus y to the third, I would get a 1, x to the third, plus a 3, x squared y, plus a 3x y squared, plus a 1 y to the third. We'll talk about how I get those in a second. But the important thing is why I get a 1, a 3, a 3, and a 1. A 1, a 3, a 3, and a 1. So Pascal's triangle gives us the coefficients in front of our terms. So this gives us the coefficients for binomial terms. Binomial expansions. All right, so the coefficients for the binomial expansions. Here's the other really crazy part that I wanted to point out to you. Let me see if I can erase all these, which I can gracefully here. That one, this one. Okay. It turns out that 1 is the same thing as 1 choose 0, right? And then, because that's the 0 row. In the second row here, or what I'm calling row 1, if I have 1 choose 1, I would get 1. And 1 choose 1, I would also get 1. In this row here, if I start off by saying this is 2 choose 0, 2 choose 0 would give me a value of 1. To get the 2, if I did 2 choose 1, I'd get a value of 2. And then if I did this one, 2 choose 2, is also a value of 1. So actually this should have been a 0. So counting upwards, you can see that we can use that choose formula to also give us these binomials. So here's what I mean by this one. Let's talk about this one, right? For this one down here, this would be the third row, this would be the fourth row. So this would be 4 choose 0 as a value of 1. Okay? 4 choose 1 is a value of 4. 4 choose 2 is a value of 6. 4 choose 3 is a value of 4. And 4 choose 4 gives us back that value of 1. So there are two ways to get these coefficients of these binomial expansions. We can either use Pascal's triangle or we can use the choose formula. So this leads us all the way up into the box number 6, the binomial theorem. Okay, you guys ready for it? The binomial theorem. If you're ready for it, grab some. If you're not ready for it, grab some tea and come back because this is going to be huge. Okay, you ready? Here we go. if we were taking a binomial, which is an expression that has two terms like this one, x plus a to the nth power, it is equal to n choose 0 multiplied by x to the nth a to the 0 plus n choose 1 x to the n minus 1 a to the 1 plus n choose 2 x to the n minus 2 a squared plus dot 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 all the way down until we get to n choose n x to the 0 a to the nth. Now I know that that looks really, really confusing right now, so I want to point out to you a couple of things. First of all, we start with the exponent. If my exponent is n, then I will have a grand total of n plus 1 terms. That's something that we figured out in the beginning. I'll have n plus 1 terms. Also, I want you to notice that as the exponent of x decreases from n to n minus 1 to n minus 2 all the way down to 0, the exponent for my second term a increases 0, 1, 2 until I get all the way back up to n. So those are always alternating. And notice that my choosing, n choose 0, 1, 2, all the way to n choose n, will always go up. So I'll have n plus 1 terms, and my exponents always need to line up. So this makes a whole lot more sense once I actually give you an example. So that'll be next. Okay, here we go. Use the binomial theorem to expand the following: x plus y all to the 6th power. All right, now I'm going to start with the fact that I know I have a power of 6. Therefore, I will have 7 terms. So I'll have 1, 2, 3, 4. I'll move this over. 5, 6, 7. I will have 7 terms, all right? So that being the case, I'm going to do my choose first. So I'm going to do the 6 choose 0, then I'm going to do 6 choose 1, and I'm going to do 6 choose 2, and then 6 choose 3, and then 6 choose 4, 6 choose 5, 6 choose 6. There are all of my 7 terms. Because I have a plus sign between them, I will have a plus between all of my terms here. So I'll go ahead and put plus, 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 plus through all these here. All right, next thing is I'm going to take the first term in my binomial, x. I'm going to raise that to the power of 6 and then go down each time. X to the 5th, x to the 4th, x to the 3rd, x squared, x, and then finally x to the 1st, and then finally x to the 0. Then I'm going to take my second term, which is y, and go the opposite direction. Y to the 0, y to the 1st, y squared, y to the 3rd, y to the 4th, y to the 5th, and then finally y to the 6th, okay? This stage right here, this is what I call the setup stage. You have set everything up, okay? Once you have the setup stage, then you move on to what I call the cleanup stage. Yikes, can't spell that word, okay? The cleanup stage. So we just got to clean all this up and make it look a little nicer for ourselves, okay? So what is the value of 6 choose 0? Well, we know it's going to be a value of 1. So I'm going to have 1 times x to the 6th times y to the 0. Plus 6 choose 1 is 6, x to the 5th, y. Okay? 6 choose 2 is 15, x to the 4th, y squared. And I got that from just looking at my calculator. Okay? Plus 6 choose 3 is going to be 20, x to the 3rd, y to the 3rd. 6 choose 4 is going to be a 15. I have an x squared, y to the 4th. Then a 6 choose 5 is going to be a 6, x to the 1st, y to the 5th. And then finally, I'll have y to the 6th. So the only thing that's left to do, which I didn't do before, is just get rid of this y to the 0, which is a 1, and get rid of this 1 over here. So when I'm all said and done, my answer is just this: x to the 6th plus 6x to the 5th y plus 15x to the 4th y squared plus 20x cubed y cubed plus 15x squared y to the 4th plus 6xy to the 5th plus y to the 6th. So that would be the binomial expansion of x plus y to the 6th. Lots of work that goes into involving that one. So there's the problem from start to finish. You got to do the cleanup stage, or sorry, not the cleanup stage. You got to do the setup stage first and then the cleanup stage and then get your answer. We'll do a couple more. Okay, this one, we're going to do 2x minus y to the 4th. We're going to expand that using the binomial theorem. This one comes with a warning. The reason it becomes with a warning is because there's two pieces that I want you to be very, very careful of. One, this whole term is a 2x, and two, there's a minus sign between them. All right? So when expanding this using the binomial theorem, you need to take that into consideration. First, we're going to start with the fact that there are 4. My exponent is 4, so I'm going to have a grand total of 1, 2, 3, 4, 5 terms. Okay? Because there's a minus sign, the very first term will be positive. The second term will be negative, positive, negative, and then positive. So the signs are going to alternate when you have a negative in between your binomials. Very important that you understand that. Then I'm going to start by building my coefficients. I'm going to start with 4 choose 0. Then I'll have 4 choose 1. Then I'll have 4 choose 2. Then I'll have 4 choose 3. And then finally I'll have 4 choose 4. Then I'm going to start my next move, and I'm going to take my 2x, raise it to a power of 4. 2x, raise it to a power of 3. 2x, raise it to a power of 2. 2x, raise it to a power of 1. Oh, excuse me. And then finally, 2x and raise it to the power of 0. Noticing that I'm raising the entire quantity 2x to that exponent, not just the x. The biggest mistake that people make is they only raise the x to the power of 4 and they forget the 2. Don't be that person. Okay? Next thing we have to do, and we'll choose blue, is we'll take our y. So we'll go y to the 0, y to the 1st, y squared, y to the 3rd, and y to the 4th, increasing. Okay, so that is our setup. Next is going to be our cleanup. So we're going to clean this whole thing up, and we're going to have this, okay? 4 choose 0 is 1, but then 2x to the 4th gives you a 16x to the 4th. Y to the 0, of course, is just 1. Then we have minus. 4 choose 1 is 4 times 2x to the 3rd is going to be an 8x to the 3rd times a y. Now, 4 choose 2 is a value of 6. 2x all squared is going to be 4x quantity squared, y squared. 4 choose 3 is a value of 4. Then I'm going to have 2x to the 1st is just 2x, and then a y cubed. And this should be plus, and this should be minus, and this should be plus. And finally, 4 choose 4 is 1 times 2x to the 0, which is also 1, times a y to the 4th. So cleaning it up even further, I get this. 16x to the 4th minus 32x cubed y plus 24x squared y squared minus 8xy cubed plus y to the 4th. And that is our answer. Okay, last example that I want to do for you guys is, say you're given an x plus 3 to the 12th. And the question is, what is the coefficient of the ax to the 5th term? All right, so here's what I want to point out to you. Let's write out the very first term, okay? A sub 1. The very first term of this sequence is going to be 12, choose 0, x to the 12th, 3 to the 0. All right, that's to me the very first term there. The next term in my sequence is going to be 12, choose 1, and this is a sub 2. Then I have x to the 11th and then 3 to the 1st. All right, the next one in my sequence, this is going to be the third term, is going to be 12, choose 2, x to the 10th, 3 squared. Okay, plus, I really don't want to write all these out here. Instead, I want to look for a pattern, and I want to know something about the fifth term here, okay? So notice that one thing that I want to point out to you is that these two numbers, 12 and 0, they always add to 12. Look at that. 11 and 1, they always add to 12. 10 and 2, they always add to 12. So we're looking for something with an x to the 5th on it, right? And we're also looking for a 12 something. And then also, do you notice that this is happening as well? This number here and that number there seem to match, don't they? That number there seem to match. that number there, that number there, they seem to match. And also, this number is always going to be one less than that one, one less than that one, one less than that one. So let's think about this. If I have an x to the fifth, that means I'm going to have a 3 to the what power in order to make the 5 and what add to 12? Well, it has to be a 7, right? So if that has to be a 7 there, then this has to be a 7 down here. And that must mean that we're looking for one more of that. So we're looking for the a sub 8th term, right? So we're looking for the 8th term of this because that's the one that has the x to the 5th exponent. So therefore, I figure out, okay, well, 12 choose 7 on the calculator is 792. Then I have x to the 5th, and then 3 to the 7th is 2,187. Multiply these two together, and you end up with 1,732,104 x to the 5th. So the coefficient on the x to the 5th term is 1,732,104. Okay, we'll do one more for you. Say you're given x squared plus 3 all to the 12th. What is the coefficient of the ax to the 8th term? So let's go ahead and build this thing. Okay, we know we're going to have 12 choose something. We know we have an x squared here, and we want to raise it to, we want to make sure that we get an x to the 8th power. So I need a 4 on the outside there. That means I'm going to have a 3 to the 8th power left over because 4 and 8 add to 12. That means that 8 is going here. So when this is all said and done, I do 12 choose 8. I get 495. I have an x to the 8th now because 2 to the 4th is x to the 8th. 3 to the 8th is 6,561. Multiply these two together, and you end up with 3,247,695 x to the 8th. And there you guys